Hi, my name is Damon Giles, and today I'll be looking at question 20 from paper 1 of the 2022 external exam paper. Question 20, a 4-mark question. The table summarises the distances in kilometres between 3 flower stores and 3 delivery locations A, B and C. Use the Hungarian algorithm to determine the minimum total distance needed to deliver flowers to all locations if each store delivers flowers to only one location. So the first thing we need to do for this question is we need to do a row reduction. So we're going to have step 1, row reduction. And in order to do a row reduction, I'm going to circle the smallest number in each row. So in the first row, the smallest number is a 17. In the second row, the smallest number is a 14. And in the third row, the smallest number is a 16. So in order to complete the row reduction, I need to draw up the matrix. And I've got store 1, store 2, and store 3. And I've got location A, location B, and location C. So when I subtract 17 from the first row, 19 take 17 is 2, 17 take 17 is 0, and 24 take 17 is 7. When I subtract 14 from the second row, 15 take 14 is 1, 14 take 14 is 0, and 22 take 14 is 8. In the third row, I need to subtract 16. So 23 take away 16 gives me 7. 16 take 16 gives me 0. And 40 take away 16 gives me 24. Okay, that is the row reduction complete. Once we've done the row reduction, we need to cross all of the zeros in the quickest way possible, which is with one line through there. Now, because we've got a 3 by 3 matrix, okay, I'm looking to cover those zeros in the quickest way possible, but I'm looking for 3 lines, not 1 line. So because there is only the 1 line there, we need to do our next step, which I'm going to call a column reduction. Okay, so for our next step, we're going to do a column reduction. Okay, so once again, we need to set up our matrix for a column reduction. Okay, we have store 1, store 2, store 3, location A, B, and C. Okay, what we're going to do this time is, once again, we need to circle the smallest number, but this time it's the smallest number in each column. Okay, and we're going to subtract that number from all the other numbers in that column. So when I take away 1 from 2, I'm going to get 1. When I take 1 take away 1, I'm going to get a 0, and 7 take away 1, I'm going to get a 6. Now for this second column here, they're already zeros, so the smallest number is a 0, so that's not going to change. And in the third column, it's a 7, so 7 take 7 is 0, 8 take away 7 is 1, and 24 take away 7 will be 17. This time, crossing out all of the zeros in the quickest way possible. So there is 1, that's that 0 gone, 2 lines, and that's that 0 gone. That's 3 lines, which is what we wanted for a 3 by 3. So we've now completed those steps. So our next step after this, once we've got the correct number of lines, is we need to construct what is called a bipartite graph. So I'm going to start with my 3 dots on this side. Okay, so I've got store 1, I've got store 2, and I've got store 3. And I'll have my 3 dots on this side. And this is going to be for location A, location B, and location C. Now when constructing, actually I'll write bipartite graph up the top there. So bipartite graph. When constructing a bipartite graph, it's important to note that we've got to connect our store number with our location for everywhere where there's a 0. So you can see here, store 1, there's a 0 for location B and location C. So for store 1, it has to connect to location B as well as location C. What we'll do is we'll make that a little bit better there so we can see that a little bit better. So location B and location C. Okay, for store 2, you can see the 2 zeros here. Okay, so store 2 has to connect to A and B, so we'll change the colour to make it a bit easier. So store 2 has to connect to A, and store 2 has to connect to location B. Okay, for store 3, it connects to location B. So for store 3, it connects to location B. Okay, so now we've completed the bipartite graph. So the next thing that we need to do is we actually need to do our minimum total distance. Okay, so we'll write over here, minimum total distance. So minimum total distance. So in order to do that, we need to do our allocations. So at the moment, we've got store 1. Store 1, it's going to store 1. There's only one option down here for location C, and that has to be store 1. So store 1 is going to location C. Okay, in terms of store 3, you can see for the red line, store 3 only has one location, and that is B. And then the last store, store 2, it obviously has to go to the other location that's left over, which is location number A. Question says, determine the minimum total distance. So therefore, to finish off the question, okay, we need the minimum total distance. So minimum total distance equals. So over here, store 1 was with location C. So back to our original question, store 1, location C was 24 kilometres. So it's 24. We're adding to that. Store 3 was location B. Store 3, location B, it was 16 kilometres. Plus store 2, location A. So store 2, location A, it was 15 kilometres. We add those three together, and for me, that comes to an answer of 55 kilometres. Now, when we're allocating the 4 marks for this question, and this is why it's important to show good communication, doing the row reduction, 1 mark. Doing the column reduction, 1 mark. Assigning each of these stores to the correct location, 1 mark. Getting the correct distance of 55, make sure you got the units kilometres. That's where the fourth mark is for question 20.